to linear functions. So function notation takes the linear equation and it replaces the y with f parentheses x parentheses. We call it f of x. So when you hear me say f of x, I'm talking about function notation. So you can have a problem that's written like this, but instead of using y, they'll use f of x equals 7x plus 5. Okay, so this is a linear function, this is a linear equation. How does it work? Very much the same way. It's almost not different at all. So let's say x is 3. Well, what do you do with the 3? Well, you would take the x and replace it with the number 3. When you plug it in as the input, you would multiply it by 7, add 5, your output would be 26. So again, we're going back to the whole idea of input is what you put into the function and output is what you get out of the function, okay? So you put it in and it gives you 26 out. Now, if you're going to write it as a problem, instead of using this diagram, you would write it like this, right? 7 times 3 plus 5. What are you doing to the x? You're replacing x with 3. So the x is now a 3. So you would keep the function notation like this. Okay, this 7 times 3 is 21 plus 5. So f of 3 is 26. When you plug in 3, you get 26. Okay, and that's pretty much it. Let's do a couple of different examples. Sometimes they will write it using different letters. So in this case, we have h of x equals negative 2x plus 3. So what happens when the input is 4? What happens when you plug in 4? Okay, so x is going to be replaced with the number 4. So I replace the x here with the number 4. First step, we multiply. But then we have to add the 3. So your answer for h of 4 is negative 5. That is what you get. Okay? And that's pretty much how you solve it when you have the x. Now, sometimes they want you to write it using the table. So it's important to distinguish your x's and your y's, because remember, the x's are your inputs. You're plugging in 1, 2, 3, 4, and you're getting out 6.5, 13, 19.5, 26. So if we're going to write a function like this, we're going to treat it like we would slope, okay? So we're going to have to find the slope here. So if you guys remember, the way we found slope was the change in y over the change in x. So look at the table. Look at how the y's are changing. They're growing. How much are they growing by? Well, if you're not sure, you can always take the second number and subtract the first number. So if I do 13 minus 6.5, I'm going to get 6.5. So this is growing by 6.5. That's your change of y. Okay? Now your change of x, 1, 2, 3, 4, that's changing by 1. So when you write your function, your slope would be 6.5 over 1, or just 6.5. Oh, we're missing b. Okay, now remember this. When we're dealing with b, you have to plug in one of your points to find out what b is. Now in this case, we're going to plug in, it can be any point you want. The easiest one is to plug in the smallest one, so 1 and 6.5. So I'm going to make x1, so I'm going to plug in 1 here, and then my f of x, the y, this section is 6.5. Because this is where the y would be. Okay, and we're trying to solve for b. Okay, what's the first thing you do? You multiply 6.5 times 1. 6.5 times 1 is 6.5 plus b. Okay, now we got to cancel out the 6.5 on one side. We're going to minus 6.5. Sorry, it's really not coming out that strong. Minus 6.5. Cancel out. Oh, they cancel out on both sides. So the only thing I have left here is b, but the only thing I have left there is 0. so b is 0. All right, so what does the function look like for this? Well, if I'm going to write the function down, here's my answer. We're going to run out of space. F of x equals 6.5x plus 0. Actually, I don't need to put that. Because it's a 0, I don't need it. I can just leave it like that, 6.5x. That's my function. Okay, let's do the next one. This one is growing by 3. The changes of x, growing by 1. So my slope is 3 over 1. So my function is 3x plus b. Okay, I'm going to show you another little shortcut, guys. The b can also be found by going backwards in the list. What do you mean by that? Well, what if instead of increasing the numbers, what if I went backwards? What if I went to the number 0 over here? What if I wanted to go back instead of forward? Okay, well, this is growing by 3. How would you go backwards? Well, you would do the opposite of growing by 3. What would be the opposite of that? Going back 3. And going back would be subtracting 3. Now, if I subtract 3, I would get 1 minus 3 is negative 2. That's my b. So my function would be f of x equals 3x minus 2. That's a shortcut to finding the b. If you guys remember, when you graph, you start at 0. 0 is that point on the y-axis. So the number at 0 is your b. So that's a faster way to do it than plugging in a point. Okay, example number 3. Let's look at example number 3. Oh, actually, it's a word problem. Let me pull that up. All right, so right here, they're wanting us to read this problem. Tamika records outside temperatures at 6 o'clock. The temperature outside increases 2 degrees every hour for the next 6 hours. If the temperature continues to increase at the same rate, will be the temperature at 2 p.m. Okay, so let's write a function for this. All right, so let me put the paper over here just so we can all see that. Okay, there is a question that goes with this, but we'll answer the question later. Okay, so let's get this information down. So it starts at 2 degrees Fahrenheit. Oh, but right here on the thermostat at 6 o'clock, it is negative 3 degrees Fahrenheit. So Fahrenheit is this side over here. All right, so b is going to be negative 3. And my slope is how much it's changing by, and it's growing by 2 degrees. All right, so that's really all I need, and it's at 6 o'clock. Okay, so my function using the linear equation, mx plus b, would look like this. Okay. Now, this is at 6 a.m. It wanted the temperature at 2 p.m. So how many hours does it take to go from 6 to 2 p.m.? What would that be? 6 to 2 p.m. Let's count it. We have 7, 8, 9, 10, 11, 12, 1, 2. How much is that? 1, 2, 3, 4, 5, 6, 7 hours. 8 hours. My mistake. I forgot. See, this is the weird thing about time. You're not going to plug in the number 2. You have to count in the hours. So from 6 to 2 o'clock, 1, 2, 3, 4, 5, 6, 7, it's 8 hours. So we got to plug in the number 8. So that means it started at negative 3 in the morning, but it's going to increase to 16 degrees by 2 o'clock. Now 16 minus 3, that'll be 13 degrees. So the function says 8 hours later, it'll be 13 degrees Fahrenheit. Okay, so that's the answer to the question. But there was a secondary question right here. How realistic is the temperature for a domain of 0 is less than x to x is less than 24. Okay, so what is this talking about? Well, guys, this is talking about a day. 0 to 24, because remember this is all the same, 0 to 24. So this is kind of calling the hours of a day. So how realistic could we use this for the day? So think about this. Think about it like this: the sun rises at 6. It would have been colder. So before 6, it was less than -3, right? So would you expect to see it increase the way this is talking about? A way to explain it is if we graph it. So if we graph this, right? Let's just say we start at -3. 1, 2, 3. That's my starting point. My slope is 2. So it goes up 2 over 1. Up 2 over 1. The line goes like this. What does that arrow mean? It means that the temperature is going to grow and continue to grow. But guys, in the real world, temperatures don't do that. Temperatures go like this. It gets warmer and then it gets colder because the sun is setting. So this is not realistic for a domain of 0 to 24, but we only needed it from 6 to 2. So the domain for x is only from 0 to 8 hours. We only used it for 8 hours. And the sun is still up at that time for these 8 hours. So that's fine. But if I wanted to know what the temperature was at midnight, I probably wouldn't use this formula. Okay? So not very realistic. Next question, actually the last question for this. I'm going to move this up. Okay. Use linear functions to solve. A chairlift starts at 0.5 miles above the base of a mountain and travels up the mountain at a constant speed. How far from the base of the mountain is the chairlift after 10 minutes? Okay, so your starting point, if we're using the linear function, right? If we're using f of x equals mx plus b, your starting point is at 0.5 from the mountain. So that's your base. That's how far away you are from the base of the mountain. So you're up half a mile. We need the m. The thing is here, the m is talking about 6 miles per hour. It's going 6 miles per hour. Okay, so then that would be 6. Okay, so there's our function. Okay. Now you would think we're good to go. We can just solve this. There's a little problem though. The speed doesn't match with the time. Guys, the time it says is 15 minutes. Uh, 15 minutes. But the chairlift is going 6 miles per hour. And that is our problem. The problem with this is that this has to be changed to hours, because this is talking about miles per hour. That was the speed. So I need to plug in hours. I don't have hours. So we have to talk about how do you convert 15 minutes into an hour. Well, how many minutes would it take to be a full hour? 60. Right now, all you have is 15 minutes out of 60 minutes. Because if you had 60 minutes out of 60 minutes, you would get an hour. You would get 1 hour if you had 60 minutes. But if you only have 15 minutes, that is a quarter of an hour. If we're going to use decimals, we would change a quarter by dividing it to 0.25. So this is what we're plugging in. We're plugging in 0.25 into this. So my x and I'm going to use a calculator. So it is 6 times 0.25 plus 0.5, and my answer after a quarter of an hour is 2 miles. That's how far up the mountain the person would be. And that's the answer.